Okay, I'm going to talk about the four normal normal distribution functions in R. We've got rnorm, we've got dnorm, we've got pnorm, and we've got qnorm. Sometimes when you indicate a function in R, you put open close brackets like that. Okay, and this screencast is going to be about rnorm, and I'll cover the others subsequently. Okay, so just a quick recap on the Gaussian distribution. The Gaussian distribution is this beautiful bell-shaped curve here. You can move it around left and right. You can move it to the right if you want, or move it to the left, or you can also have a wider distribution or a narrower distribution. Okay, so it's this beautiful Gaussian, beautiful bell-shaped curve. Gaussian, sometimes called the normal distribution. And indeed, normal distribution is the origin of the norm bit here. Okay, so I'm going to show you how it works. Go over to R, and the first thing you do with any new function in R is to get help on it, and you go question mark R norm. Okay, and it fires up this server here, and you can see that all four of the functions are documented. dnorm is there, pnorm, qnorm, and rnorm is the one I want to cover, which is this one here. So R is random numbers from the normal distribution, and n is how many we're going to get, and I'll cover these arguments in a minute. Okay, so let's just try it. Let's go rnorm, and then round brackets 10. So the 10 there, this 10 here tells you how many normal numbers to get, and they're all random numbers from the Gaussian distribution. So this one here means that that's the first one, that's the second, that's the third, that's the fourth one, fifth, sixth, seventh one there, eighth, ninth, and 10th one there. So there they are, random normal numbers. If I do it again, I can do that by hitting the up arrow to get the same command again, and we get different numbers back. We get different numbers back because it's generating them randomly, freshly each time. Let's just try that again, and here we see the numbers are varying and jumbled about. If I do something instead, if I do something like rnorm 20, we get 20 numbers here, and we can see that's the 19th number there, that's the 20th, and so forth. Keep on doing that. Okay, so there they are. To get a sense of how they are arranged, we can do hist rnorm of, let's say, 10. And we get this nice histogram appearing here. And you'll see that this image here is not showing this classical bell-shaped curve, which is a bit of a puzzle until you realise that we've only got 10 numbers here. And if I do that command again, hit the up arrow, you can see how it's varying about. It's very, very chaotic. If I increase the number of observations to, let's say, 100, there you go. It's looking a little bit better, a little bit more. You see, you're beginning to see this shape here. But there's still quite a lot of scatter. Of course, if I put enough zeros, what's that, 100,000? And suddenly now we can see this beautiful Gaussian picture emerging out of the gloom. We see this nice bell-shaped curve. I could make it a bit bigger even. If I stretch it over here, we can see this nice Gaussian curve going up there. I'll just play with this command a little bit. If I go color, comma, color equals, let's say, grey. Slightly more professional looking here, but it's the same idea. So we've got random numbers from the Gaussian distribution. What I want you to observe is that most of them are between about plus and minus 2, between minus 2 and plus 2 here. Of course, they go out there. You'll notice when I draw the picture here that the curve gets smaller and smaller and smaller and smaller, but it never actually goes to zero. This height here never goes to zero. I'll return to that later. But for the moment, what that means is that random numbers from this distribution can be arbitrarily small or arbitrarily large. There's no upper limit. It doesn't have a cut-off value. Let's just make that a bit bigger again. There we go. I can get a slightly different perspective on the Gaussian distribution by, if I just go back to my command here. And by the way, while I'm talking, I want you to do this alongside. It's one thing to watch, it's quite another thing to do it. Let's plot rnorm 10. Let's have a look at that. That's a little bit difficult to understand. Let me just try with a higher number. Let's say 1,000. So what I'm going to do is just plot 1,000 normal numbers. Ah, that's nice. Oops. That's a nice picture. So what we've got here is, there's the first one, there's the second, third, fourth, fifth, all the way up to 1,000. And we can see this range, that most of them are between plus and minus 2 here. In fact, if I put a grid on it, we can see grid. We can see that there's 2. You see, there's a few outliers here. What's the biggest one we've got? That one there's 3 point something, maybe nearly 4. And down here, let's try that again with a fresh set of numbers. And we get again, oh look, there's one that's almost as low as minus 4 there. We can get this nice picture, grid, get this nice picture of Gaussian distribution just by looking at how the numbers are dispersed here. It's a very valuable thing to do. If we go back to the help page, rnorm, question mark rnorm there. So you put the question mark and then norm. Where did that go? Not sure where that went. Let's have another try. Here we go. We're looking at this. We can change the mean and the standard deviation. So let's just try that. I'll just show you that again. I think it was, yeah, there it is. We can change the mean and standard deviation. So what this means here is that the mean equals 0 unless you tell it something different. And if you look at the commands I've been giving are, let me just shift that about, let me just move that across. The commands I've been giving, it's just rnorm 1000, so it said 1,000 numbers, but it picks up the mean and standard deviation from here. So it knows that the mean I want is 0 because I haven't overridden it, and the standard deviation equals 1. So let's just go through that. Let me try the histogram, I guess. Hist, let's say rnorm of, let's say, 100,000. There's my histogram, which we've seen. If I say comma mean equals, let's say, 5, you can see how in the previous command that, let me just do that again. I've lost my place. Hist rnorm 1,000, 100,000. It's picked up the mean of 0 from the help page, so the mean is equal to, or accurately equal to 0 here. Now what I'm going to do is to change the mean to 5. And if we look at this now, instead of clustered around 0, they're clustered around 5. You see, some are above and some are below 5, which is the central value. And in fact, if I go rnorm, let's just say 10, mean equals 5, we'll see, look, it's 6 point something, 6.4, 0.5 point. They're clustered around the mean value of 5, which is what you'd expect, really. Doesn't need to be positive. I can say mean equals minus, in fact, let's make it minus 8. Here we go, and now we've got, look, minus 6, minus 7, minus 10, minus 8. They're clustered around the mean value of minus 8. And I guess I could plot those. There you go. It's not, oops. Not sure why that happens. Not sure why that happens. Okay, instead of 10, we'll try a few more. We'll try 1,000. And here you see from the vertical axis, it looks just the same, but it's rescaled the axis to be clustered around minus 8 because the mean here is, of course, minus 8, which is quite nice. I can also go, let's go back to histogram, rnorm of, let's say, 100,000 values, standard deviation equals 10. Well, let's do standard deviation equals 1, which is the default first. And you'll notice that the width, I'll define it formally later, but the width is about plus or minus 1 here, because the standard deviation is equal to 1. But I can make it any value I like. Let's make it 10. And now the mean is still 0, but it's going to plus or minus 20, because it's 10 times wider than the standard distribution, simply because I've specified the standard deviation equals 10, which is quite nice. And of course I can change both of those at the same time. Mean equals, let's say, 100. Standard deviation equals 10. There we go. So now they're clustered around 100, and they go plus or minus 10 on either side, which is quite nice. Okay, I'm going to stop there. rnorm, and again, I'm very happy for people to view this, but you'll learn so much more if you get R out and fire apart and actually type those commands in, because the only way to learn is to do, really. Okay, I'm going to stop there.